My name is Whitney Lee. I'm a developer advocate, and I'm here with Raghd.
Hey Whitney, hey everyone. I'm Raghd, Hamzeh. I'm one of the maintainers on the Open FGA project.
Thank you so much for sharing your time and your expertise with us today. We just had a conversation that was almost 2 hours long where Raghd taught me about Open FGA from scratch. I knew nothing, and now I know all of this. But meanwhile, here's a recap for you. To give us context about Open FGA, can you paint a picture of what the world was like before it existed?
Before Open FGA, we used to have a different access control mechanisms. The two most common ones are role-based access control, or RBAC, and attribute-based access control, which is ABAC. RBAC is a way to allow users to grant user access based on the role. Attribute-based is based on whatever attributes either the user or the object may have. The problems with those in role-based is it's too coarse-grained. Problem in attribute-based, it's very hard to scale.
Excellent. And we're going to dig into that a little bit more shortly. But in the meantime, let's start up top with what exactly is Open FGA?
Open FGA is an authorization engine, which is an API or a library. It's meant to be a high-performance, flexible authorization engine, and it's built specifically for developers to enable fine-grained authorization at a large scale.
FGA stands for, the F is fine and the G is grained and the A is authorization. So what I want to say is, as a really new person to tech in general and to the security space, it was good for me to know that authorization is different from authentication. Authentication is getting access to the system for the first time, like a login, and authorization is what you can do once you're in the system. So what does it mean that it's relationship based, that it's not just role based or attribute based?
It means instead of looking at the user's role in the system or the an object's attributes, it looks at how a user and an object relate to one another. So now we're looking at two entities and the relationship between each other. Basically, when you're saying a user is a viewer of a document, or a user is a follower of another, or a folder is a parent of a document, or an organization is a parent of a team, we're indicating relationships. We're not indicating a role, and we're not indicating an attribute of any of this.
So this relationship is made up of three pieces. So there's one or many users, but the user isn't necessarily a human user.
Yes.
And then there's kind of an actiony word, like a relation word. And then there's the subject, which is always a single thing, a single object. Moving on from that, to really help me understand about how it works, I needed you to further explain the problem space for me. And so what you taught me is that attribute-based policy engines, what they have to do is they have to make calls to different databases to even get the information about these three fields that we were talking about, these three pieces. And then once it has that information, then it needs to perform computational logic. And then it can decide whether someone has access. And none of that is happening until check time. So what you very succinctly said is difficult about the attribute-based part is that it can be, it's difficult to scale. So what I would like for you to describe right now is how Open FGA does it differently and how that helps with scalability.
The way Open FGA does it is it asks the developer, whenever something happens in the system, whenever something changes that affects authorization, tell us. So as users are getting onboarded or as documents are being shared, all of these are actions.
Before this access point, nobody's trying to access anything yet. This is just a relationship that's being defined. Yeah. Mm-hmm.
Yes. And whenever this happens, you would tell Open FGA. All of them are in the form of these three fields. User X is now part of organization Y as a member. When they're deleted, just tell us that this is no longer true. So you're telling us this at the time this is happening. That means at the time of check, when you then tell us, okay, can user X view this document, we would already have in OpenFGA all the information in order to understand whether they do or do not have access. We do not need to go and look in other databases and gather it. We would look in our database, which is usually co-located, again, to reduce latency, which is insanely important here.
So OpenFGA gets the user identity from wherever, doesn't care about where that comes from, and then it calls the OpenFGA server API. At that time, discovers whether or not the human is allowed or process is allowed to do the thing that it's asking to do. The relationships attribute base that has to call for, those are already stored. And these are all separate from the application itself. How does this help scalability?
This is separate from the application code, but also it's separate from the application database. If you're a lot of load on your database, it should not affect this. If you're getting a lot of people trying to access things, your production database should not go down. And you're also the fact that because this data is now pre-gathered, you're saving on all the time it takes to understand what data is needed and the time to go and collect it before sending it to the policy engine. So all of that is no longer needed because OpenFGA already has that stored, so can just quickly go and look at it.
And one more thing I think worth saying is these two are not mutually exclusive. So OpenFGA can't do like checks based on label or something. It only does relationship checks. So what did you call it? Any attribute on any attribute?
With an asterisk that we've rolled out like a version which does allow attributes to a certain extent, but because it's shoehorned into a relationship-based world, it might not fit all use cases. And there's use cases where you would have like pure attribute-based, where OpenFGA would not be like the best solution for you.
That builds trust, I think, that perfect honesty. And so what are some really good use cases for OpenFGA?
The first one that comes to mind is sharing, because it's something that used to be a lot harder because you need to store all this in your database and traverse it. And now sharing with OpenFGA is as simple as like telling us, so I shared a document with you, you tell us, okay, Whitney is now an editor of a document, and that's it. So sharing is now so much easier. I'm not saying it was impossible before. You can do a lot of things with application logic, but it's just so much simpler to integrate, so much simpler to build.
And faster.
And faster, exactly. Like any application that has sharing, whether sharing with a single person or a group of users, benefits a lot from this. So whether sharing like documents internally or publicly, or this folder that has like 300 nested folders under it to be shared with that one person, all of that is extremely easy to implement.
What I think is important to understand, besides the way OpenFGA stores relationships separate, like understand the authorization model itself.
The authorization model is the second like piece of information OpenFGA needs, alongside with the data we talked about previously. The authorization model is static compared to the data, which is dynamic. Data changes as people are performing actions, as the documents are being shared. Data is constantly changing. The model is static. You write it, and you'd only change it if you're implementing a new feature or changing your feature set. Folders, you have users, you have organizations. Each one of those is a type, and it kind of represents the types of objects or types of entities in your system and how they could potentially relate to one another. We're talking about a lot of digital space, but we can talk about the WeWorks of the world, where you can maybe access one place and not another, or like we can access some rooms but another, but maybe the support staff can access all rooms. All of those are types of object. The room is a type of object in that case. Basically, OpenFGA would now use that static model in order to help it traverse the data you've already given us and try to find a path. So when you're calling check, OpenFGA will look at the model, see, okay, you're calling a check on this folder. What does this mean? And it will help it use that information to traverse the data. If it finds a path from the object to the user according to that action, this is allowed. If it does not find a path, it'll tell you, no, you're not allowed. Like the user is not allowed to perform this action.
So the OpenFGA authorization model has types of these three fields, like types of users, types of relations, types of objects that can be acted upon. And then the data is actually specific information.
So it's not types of users, it's only types of objects. And under object, it's the what are the possible relations, and then how they could possibly relate. So a user could be a member of an organization. Like, so it's the types of objects and what are the possible relationships or relations between them.
And then the data are like specific people or specific like systems or specific documents or whatever.
Dev world, it could be like you have a class and an instance of a class, something like this.
So having this authorization model, one thing you said is it's immutable. You like kind of talked about some benefits of doing the authorization model this way. Will you dig into that now?
If deployed OpenFGA in production, that you can then target a particular model, knowing it will never change. No one can go and update that model and suddenly break your production. So long as your production system is targeting a particular model, all your checks will be going according to that model. Meanwhile, you want to modify, you want to update your model, you want to include new features. What you can do is still create new models and test them against your production data, because the data is still there. You're just using a different version, a different model with the same data, and ensure and basically run tests and understand how this new model would perform. Once you do that, and now you're ready maybe to go to the next level, something else you can do is in your application, you can do shallow checks. So you'd still be checking against the current existing authorization model, but run a shallow check every time against the upcoming one, and then logging and alerting on anyone you notice any discrepancies. If now everything matches, you've noticed, okay, everything's good, give it a bit of soak time, then you have the confidence to say, you know what, my model is working in testing, my model is working when I tested manual production, and my model worked when I deployed it. So you know it's at least as good as your previous iteration. You have the confidence to basically roll it out.
One thing I like about the Open FGA way of doing things is that the system is auditable. Like you can see what's happening, like which documents does Whitney have access to in the whole system, when before that sort of logic was within each application and it wasn't so easy to figure out.
Like the idea that the data resides in your production system and the logic resides either in a policy or in your app code means you have to go, like, trying to understand who has access to what, trying to audit that. You have to go look into the app code and understand that. With OpenFGA, you have the model. The model really describes a lot of the overview of who should have access to what based on things, but you have the data, so you can literally query it separate from your app. You're not using the app. You can use just an API. Tell me who has access to this document. Tell me what does this user have access to. It's easy to envision being able to see overly broad, like overly provisioned users who have access to more than they should. You can notice when you have documents that are too public, you don't want, like, something has been there, we should have restricted access there. That's definitely doable in terms of auditability. Additional thing is, because now all the calls are being called through check, you can log them. So you can log the decision at a certain important time. When that person called check last week, what did we respond? Same when updating the facts, you can potentially add metadata. We don't support natively, but like think of it in the future, we can add metadata where this person is the one who shared and this is why they shared it. So later on, when you're trying to figure out why someone has access to something, you have the full picture. You understand why they were granted access, and then you can say, okay, this is no longer needed maybe, or like this can stay.
And then the last big benefit I think that you told me about, at least, is that you talked about developers switching between teams and how this might be helpful for them.
Because now the language we're using to enforce access, which is just calling check, it means there's less cognitive load on developers. They don't need to learn how each project is doing its own authorization, basically. You don't have to understand all that. As a developer moving to a new team, you already have all the skills to take on authorization there. Additionally, think about it in terms of several teams. When you have two different teams and you're trying to integrate them. So in terms of Google, think Gmail. When you try to send an email with a link to a Google Drive document, it will tell you have not shared this already. It's able to do that because there's that singular central authorization service. Does this user have access to this document? Integrating two services now is easy because you're talking the same language in both.
That makes so much sense. And then will you please tell us about the future, some things you have planned?
Near term, definitely things that are on our mind that we want to focus on now is things like being able to give access to smaller chunks of the model. So the model right now is can be big, especially in bigger teams, enterprises, the Atlassian, Google of the world. Ideally, what we want to do is like have sub-teams have ownership on some parts of the model. So you can say the Jira team, for example, just handles the part of the model that's specific to Jira, versus the Confluence team handles the part with it that's specific to Confluence. But this is the first step in modular models. The next step in modular models is at some point we want to add more, we call this FGA on FGA, or authorization for what you can do in FGA. So who can call a check? You can say this service can call a check on only these types, this service cannot. Another thing we're considering is search with permission. This is something that we need to solve. The idea of if you're implementing an interface where people are searching for a document, the app needs to understand access control permissions and know to only search within those specific documents that the user has access to, and sort them by whatever arbitrary field the user has set. So because OpenFGA does not have all that data, it cannot do this work for you. It can tell you only what this user can access. Unfortunately, at scale, if the user has access to 10,000 documents, 10 million documents, it does not make a lot of sense at that point in time for OpenFGA to send you a list of 10 million documents, which we will then feed. So what we want to do is have like some sort of local index where you can store the expanded version of things you need to search for. So usually what you do that is in viewer, for example. So if they can view that, so you can have them stored locally. You'd feed that info from OpenFGA, store it locally, and then be able to do joins in your data. So when you're searching, it's a simple query to your database, but with joins to some permission-enriched data. The final part is to have some sort of standardization, a sort of common language for authorization. It becomes a standard like adopted industry-wide. This would help general security practices if people can speak the same language, can perform the same set of tests to do authorization. But it would also help even things like identity governance, where if you join a company and you want to be provisioned access to 10 services or 20 services, instead of the identity governance needing to understand the language and implement with each specific service, if they're all talking FGA, the identity governance can just update that access in a common language. That's where common, like having this as a standard, as a common language, really, really helps it.
Absolutely. And we see that in the authentication space.
Yeah. So authentication has already figured this. There's no reason we cannot figure it for authorization.
Absolutely. Is there anything else you'd like to say about OpenFGA in closing? Maybe how to join the community?
Please do join the community. We're on Slack, the CNCF Slack, on GitHub. Yeah.
Great. Thank you so much. I've learned so much from you today. And thanks to everyone who watches this. Goodbye.
Bye. Thanks, Whitney.